Hi everyone, we're going to do a conduction example problem. So here goes. While sitting in the stands at a Packer football game, we have a fan named Vince Bart Brett Aaron who is wearing a wool coat with a surface area of 1.6 square meters. The wool coat is 2 millimeters thick. The outside air temperature is 11 degrees Celsius, and our Packer fan's skin temperature is 36 degrees Celsius. At what rate is he conducting heat through the wool coat? Well, first off, the name Vince, Brett, Bart, and Aaron, if you live in the state of Wisconsin, somewhere in most family trees, there's going to be somebody with one of those names, but you got to be a Packer fan to get that. All right, we're talking about thermal conduction, and our thermal conduction equation is this. Delta Q over delta T is going to be the thermal conductivity equation, change in temperature, surface area, thickness of the material. So we want to know at what rate is the heat conducted through the wool coat. So this is what we're looking for, the amount of energy per unit time. So the thermal conductivity constant for wool, where do we find that? Well, you can find that either in your textbook or you can find it in your physics constant sheet. The thermal conductivity constant for wool is 0.040. The change in temperature, well, on one side of this wool coat, the temperature is 36 degrees. On the outside, it's 11 degrees. 36 minus 11 degrees is 25 degrees Celsius. So the change in temperature is 25 degrees Celsius. The surface area of the coat is 1.6 meters squared. And the distance, the thickness of the coat is 2 millimeters. Well, that's 2 times 10 to the negative 3 meters. And I better go back and find my units on my thermal conductivity constant. I was getting all cavalier here and didn't have it, so I'm going to look that up. It's going to take me a momento. Thermal conductivity constant. This is going to be joules per, on the bottom, seconds, meters, degrees Celsius. Wacky units. Okay, now let's take a look at this. So, degrees Celsius, I'm going to cancel degrees Celsius. Meters squared, I've got a meter here and a meter there, and I'm going to end up with joules per second, and energy per unit time is joules per second. So when I do the math and I multiply and divide, I'm going to end up with 800 joules over seconds, and a joule per second is a watt. So basically that's like 8 100-watt light bulbs. He's giving off a lot of heat. I suggest something thicker than that coat sitting outside. All right, we'll see you later. Bye-bye.